Morning, Algebra 1. I am going to show you how to solve systems of equations by substitution. And if you remember in the last section or two, you learned how to solve systems of equations by graphing, which basically is just graphing two lines and looking for that point of intersection. You're still doing that, and there are actually three methods you can use. So this is method number 2. So I'm going to write method number 2. Okay, you don't need to know that it's method number 2, but there are 3 in all. So solving systems of equations by substitution. What you are looking for is you are looking for one of the equations where x is already isolated. They're telling you what the value of x is, and it's given to you as this expression. And if you know that x equals 2y minus 8, then if you look at the first equation, you can indeed substitute 2y minus 8 in for the x value. So we have 3 times 2y minus 8 plus 4y equals 36. So all I did, you can see I have the exact same equation, and instead of writing the x, I replaced it with its equivalent value, which is 2y minus 8. From there, you just go to solve this, and I'm going to solve this pretty quickly because I know you all know how to distribute. You do not always get nice answers, but Mrs. Collins was really friendly with her examples, and I made sure that my answers came out nice. So it tells you y equals 6. The reason I put the cloud around this, or this little bubble kind of spot, is because I know that I still have to find out what x is, because we are looking for a point of intersection. And if x equals 2y minus 8, and I know that y is 6, then I know that x equals 4. So if you were to graph these two lines on a coordinate plane, you would find out that they intersect at 4, 6. A little easier to do with substitution, or the third method, which I'm not teaching you yet. In example number 2, you can see that this equation and this equation, they're both written in almost standard form, where the x's and y's are on the left side. So you have to decide whether you want to get x by itself by subtracting y, or get y by itself by subtracting x, or you really could get this x by itself, which would be done by adding 4y, then dividing by the negative 3, or you could get this by itself, which would be done by adding 3x and dividing by negative 4. Obviously, one of the first two methods is the preferred method. I'm going to get y by itself, and I'm going to tell you that y equals 2 minus x. And then I'm going to immediately put the cloud around it, and I'm actually going to go right, and I'm going to draw the arrow to the y. Because now, instead of writing y, I'm going to replace that with 2 minus x. Go through and we'll distribute like we normally would. So I get x equals 17, which I don't think was my original purpose. Let's see, did Mrs. Collins mess up? So I got 2, I have to look back at my work here. 2 minus x went here. I didn't write anything wrong. I didn't mean for it to come out like this though. Negative y plus 3. Oh, I know what I did, I think. Oh, I'm not sure. Negative 3x minus 4 times 2 minus x equals negative 9. So I get negative 8 plus 4x, negative 3x. Oh, no, negative 3x plus 4x is x. Oh, look what I did. I dropped my negative sign. That's where I messed up. So then when I add 8 here, I get negative 1. See, Mrs. Collins messes up too. Once you know x equals negative 1, come back up here to your cloud. 2 minus, and my x, which is negative 1, so y equals 3. So these intersect at y equals 3.